Hello everyone, I am Dr. Godundraman. In this section we are going to discuss with type 2 problem of one-dimensional heat equation with the temperature at one end 0 and the other end non-zero and steady state condition. Before going to solve the problem, what is a steady state condition? The condition at which the temperature remain constant when the time increases is called as steady state condition. The temperature function is nothing but u of x comma t will be a function of x alone in the steady state condition. When x alone, then dou u by dou t equal to 0 under steady state condition. Now we consider one-dimensional heat equation. When one-dimensional heat equation, so this is our heat equation. Dou u by dou t equal to a square dou square u by dou x square. When I substituted steady state condition dou u by dou t 0, then dou square u by dou x square equal to 0. Since u is a function of x only, therefore dou square u by dou x square equal to 0 can be written as d square u by dx square equal to 0. Because dou square u by dou x square is a partial differentiation, this is the ordinary differential equation. In this equation, d square u by dx square, integrate twice, then we should get the value. The solution is nothing but u equal to ax plus b. Now its a consideration is nothing but u is a u of x. What is the meaning this? U of x equal to ax plus b. So this is a meaning because u depending on x variable. Now we are going to discuss with the problem. The problem is nothing but a rod of length L has its ends A and B kept at temperature 0 degree Celsius, 100 degree Celsius until steady state condition prevail. If the temperature at B is reduced suddenly 0 degree Celsius and kept so while that of A is maintained, find the temperature u of x comma t at a distance x from A and at time t. Now here what is the condition? A rod of length is given and 0 degree Celsius and 100 degree Celsius until the steady state condition. What is the steady state condition is mentioned that a steady state condition is nothing but now some cases, correct? What is the cases? When the time increases. Okay, when the time increases, the condition which temperature remain constant. So therefore now the steady state condition is nothing but when I'm writing here steady state condition dou u by dou t equal to 0. Now this condition to substitute one-dimensional heat equation. One-dimensional heat equation. What is one-dimensional heat equation? Dou u by dou t equal to a square dou square u by dou x square. In this equation to substitute dou u by dou t 0. When I substituted dou u by dou t 0, then it will coming with d square u by dx square equal to 0. From this equation the solution is nothing but u of x equal to ax plus b. So this is our solution for equation. Now what is the condition is given? Just consider some rod. So now I consider this is a rod. In this rod A and B two end, A one end, B other end. Now the length L is nothing but x0 to xl. In this cases what is a u? U equal to 0 degree Celsius and another end u equal to 100 degree Celsius. So until steady state condition, therefore we have using under steady state condition. So this is our equation, that is a meaning d square u by dx square is a equation, u of x ax plus b is a solution, and now I consider this is the equation number 1. Then condition. What is the condition given the problem? So first condition x0 because the length x0, then other condition xl. When x0 u of 0 equal to, because this is the boundary condition, u of 0 equal to 0, then u of l equal to 100 because this is a 0 degree temperature, 100 degree temperature. Now I'm going to apply with this condition to the solution. We should get the value of u function of x. Now using condition 1 in equation 1. So this condition x 0. When I substituted x 0 in this equation number 1, u of 0 equal to a into 0 plus b. So u of 0, the first condition value 0. 0 equal to b. Now I consider this is a second equation. Substitute second equation in first equation. When I substitute here, u of x equal to ax. Because of the b value 0, now I consider third equation this. Next, using second condition. What is the second condition? Using condition 2 in equation 3. Put x equal to L. When I substituted x equal to L in the third equation, this is the third equation. So u of L equal to AL. So what is the u of L value? 100. Now what is the A value? 100 by L. Now I consider this is the fourth equation. Substitute fourth equation into the previous equation is nothing but substitute fourth equation in third. Therefore u of x equal to 100 by L into x when the t value 0. So this is a function of x value until the temperature one end 0 degrees Celsius, another end 100 degrees Celsius. Now what is the problem next to mention? What is the mention? So look at here. See, if the temperature B reduced suddenly to 0 degrees Celsius and kept so while that A is maintained, find the temperature. So this form, this rod we consider again. Now what is the changes? The changes is nothing but, now this is a rod I am consider. In this rod, A one end, B another end, x 0, x L, this is a length. So earlier what is the value? This U temperature 0 degree temperature and this U temperature 100 degree temperature, and then suddenly reduced to this B to 0 degree Celsius, but this AN no changes, again 0 degree Celsius. When the reduction, the reduced degree temperature started, then the steady state condition to active with time. Therefore when the time u of x comma t, correct, u of x comma t is nothing but time. So when the time is activated, because of the reason it will be reduced. So when time is activated, now the one dimensional equation we know that, right? This is a one dimensional equation, heat equation. One dimensional heat equation is nothing but dou u by dou t a square dou square u by dou x square. In this equation, what is the suitable solution? The suitable solution is nothing but u of x comma t equal to a cos lambda x b sin lambda x into e power minus lambda square a square t. Now I consider equation number 1. Now when the rod temperature reduced, one end no changes, other end 100 changes to 0, therefore the boundary condition. What is the boundary condition? The first condition, the length x 0, therefore u of 0 comma t 0, x 0. Then another one, u of the length L comma T equal to 0, X equal to L. So this is a boundary condition. Next, what is the initial condition? The temperature U of x comma 0 equal to, so U of x until the steady state condition, U of x when t equal to 0. Now see the equation. What is the equation? This equation I consider fifth equation. Okay, so this fifth equation I am going to substitute for this condition 100 by L into x when t equal to 0. Now as usual the procedure, same procedure to follow. Now nothing but using condition 1 in equation 1, using condition 1 in equation 1, put x equal to 0. So when I am substituting, applying x equal to 0 in equation 1, U of 0 equal to t. So U of 0 comma t equal to a cos 0 b sin 0 into e power lambda square a square t. This first condition, U of x comma t value 0. So 0, then a cos 0 1 sin 0 0. Therefore cos 0 1 sin 0 0 e power lambda square a square t. So 0 equal to a into e power lambda square a square t. Here e power minus lambda square a square t is non-zero, so I am taking left hand side 0, a equal to 0. Now I consider this is the equation number 2. Substitute the two equation in the previous equation 1. So what is the first equation? U of x comma t equal to a0, therefore only the b term, b sin lambda x e power minus lambda square a square t. Now I consider this is equation number 3. Next, using condition 2. Using condition 2 in equation 3. What is the second condition? X equal to L. When I substituted x equal to L, U of L comma t equal to b sin lambda L e power lambda square a square t. Now what is the value of U of L comma t? The second boundary condition value 0. Then b sin lambda L e power lambda square a square t. Now b non-zero, then this term non-zero, therefore to take in the left hand side the values should be 0 equal to sin lambda L. The 0 may be rewritten as sin n pi equal to sin lambda L. Therefore n pi equal to lambda L, then lambda equal to n pi by L. Now I consider this lambda value equation number 4. This fourth equation substitute into the previous equation. Substitute fourth equation into third equation. So U of x comma t equal to b sin n pi x by L e power minus lambda square is n square pi square a square t by L square. Now I am going to consider this fifth equation. Before that, we just consider this one constant into the generalized constant. So U of x comma t equal to n from 1 to infinity bn sin n pi x by L e power minus n square pi square a square t divided by L square. This equation I consider number 5. This is a fifth equation. Next, condition to apply third condition. So using third condition in equation number 5. Third condition, equation number 5. So third condition is nothing but put t equal to 0. When a t equal to 0, U of x comma 0, then n from 1 to infinity bn sin n pi x by L e power 0. Therefore U of x comma 0 is initial condition. The function U of x is nothing but 100 by L into x then n from 1 to infinity bn sin n pi x by L. From this, whenever I am looking, this formation is nothing but half range sine series. So what is a half range sine series? Is nothing but f of x equal to n from 1 to infinity bn sin n pi x by L. Now what is a bn to calculate? 2 by L, 0 to L, f of x sin n pi x by L into dx. This is a half range sine series form. So therefore now this 100 value, so this is a f of x equal to, therefore f of x value is nothing but 100 x by L. Now bn to calculate 2 by L, 0 to L, f of x is nothing but 100 x. Therefore f of x 2 by L, 0 to L, 100 x by L sin n pi x by L into dx. Now the constant term, take it out. Therefore when the 100 I am taking out 200, L I am taking out L square, 0 to L x sin n pi x by L dx. For here using Bernoulli integration. What is a Bernoulli? Integral uv dx equal to u v1, u dash v2, u double dash v3 and so on. This is a Bernoulli function. Now we have to consider this u, this whole term v. Therefore u we are going to differentiate v integration. So what is the differentiation? Differentiation is nothing but u. So u equal to x. Then integration v equal to sin n pi x by L. So when I integrate this v1 minus cos n pi x by L by n pi by L. Again integration minus sin n pi x by L by n pi by L square. Now this derivative u dash equal to 1, u double dash 0, u triple dash 0. Now what is the formula? U v1. So u v1, u dash v2, u dash v2, u double dash. So u double dash 0. So I stop up to the term. Therefore 200 by L bn u v1 u x v1 minus cos n pi x by L by n pi by L minus u dash 1, then v2 minus sin n pi x by L by n pi by L square. Now the limits is nothing but 0 to L. So where to substitute the limits? Upper limit and the lower limit. Where? In x. Where x? To substitute upper limit and the lower limit. So when I am substituting x, therefore 200 by L. When I substituted L here, L cancel. Therefore here L minus L and then cos n pi by n pi by L. Then minus minus plus sin n pi plus sin n pi 0 minus lower limit 0 into any term 0, then lower limit minus minus plus minus, therefore sin 0 0. Therefore this term is nothing but 200 by L minus, to change this denominator value, so L square n pi minus 1 power n. To cancel this L, therefore minus 200 L by n pi into minus 1 power n this is a Bn value. This is a Bn. Now I'll take this is a Bn. You substitute this Bn value into the previous equation. So what is the previous equation? Equation 5. Therefore u of substitute, this is a 6. Okay, substitute 6 in 5. U of x comma t equal to, u of x comma t equal to n from 1 to infinity. Substitute Bn value minus 200L by n pi minus 1 power n into sin n pi x by L into e power minus n square pi square a square t by L square. So this is our final equation, u of x comma t. Thank you.